All right, so a couple things I noticed when people were working on the assignments yesterday, there were just a few minor issues. Let's look at a couple quick examples and you can go continue working. I put up another assignment, so we got, I can't remember if there maybe are two new, I don't know, was the quadratic formula one up yesterday? Yeah, okay, so it's just one new one. It's not a big deal. More stuff on the quadratic formula. So what about this though? This has to do with completing the square. It wants us to convert the quadratic function to vertex form. So what's vertex form? Y equals what? A, good, times the quantity, x minus h, I heard. Almost.
Okay.
What am I forgetting here?
Squared.
Squared, good, plus, okay. Okay, good, so that's vertex form. Now notice that vertex form of the three forms that we have for a quadratic function, vertex form is the one that has a perfect square in it, right? It's got x plus or minus some number of quantity squared. So we've got to complete the square to go from here over to there then, right? So what's that look like? Completing the square. You got to complete the square on this function to put it into vertex form. Okay, good. We want to get, our goal is we want to get on one side of the equation, we need to get something that looks like x squared plus bx, right? So that we can add the right number to it to create a perfect square trinomial. Right? So we got to get rid of the 66 because here's what we want to start with on the right side. Agreed? Okay. So if I subtract 66, I just get y minus 66 equals x squared minus 18x. And now my goal is to get the right side into the form of a perfect square trinomial, right? Okay, so what's the number to do that? What's the number that I need to add to this side? -9 squared, right? Half of b squared. So b is -18. So we're going to add the square of -9, which is what? 81. So we have to keep both sides balanced. It's an equation, so we're going to have to add that same 81 to the left side, right? Now on the left side, we can simplify a little bit here. We can just combine these like terms. What is -66 plus 81? I heard it. 15? I think I heard it. 15. And the other side, our goal is to turn this into, the whole point of this, to create that perfect square trinomial was so that we could write it as a perfect square, right? What does it factor into?
X squared.
Okay, right, so x plus half of b, which is -9. So I can say x minus 9. Whatever is the number, half of b, the number that's being squared is the number that gets paired with x inside the perfect square, right? And so now we're just really one step away. What do I have to do to put that into vertex form? Yeah, or add, subtract 15 from both sides, right? I've got to, does that make sense? So we get, I want to get the y by itself. Oops. Quantity x minus 9 squared minus 15, right? Yeah.
So the x minus 9 squared, is the -9 there because it's half of -18 or because it's the other?
No, yeah, that's exactly why. It's half of, it's -9 because it's half of b.
So what
Okay.
happened to the other?
Say it again.
So what happened to the -9 squared?
It should be the other side.
Oh,
Yeah.
on this side right here?
No, plus negative, like x.
Oh, right here.
Minus 18x plus, yeah.
Okay, because the pattern is, in order to get a perfect square trinomial, we have to add to these x squared plus bx, we have to add half of b squared. Okay, and then when I do that, that trinomial factors into that.
Oh.
Okay, here, I can show you that, because we can actually do the factoring. If I make that an 81, what if you had started with this last semester? If I had said, factor this, x squared minus, was 18x, right? Minus 18x plus 81. Can we find magic numbers? What are the magic numbers that multiply to positive 81 and add to negative 18? Negative 9 and negative 9. See, it's always going to work that way. By adding that number to the x squared plus bx term, we always make a perfect squared trinomial that has to factor that way. Okay? Yes?
So like on the thing that we just put, would the A be 2?
So with on this thing right here?
No, not on that.
On this?
Yeah.
Yeah, okay, what is A?
2?
No. What's the number, what's the coefficient out there? Yeah, 1.
Then what happened to the 18?
The 18, well, the 18 got absorbed into this x minus 9 quantity squared. Right? We know.
Oh wait, no, I didn't know.
You get it?
Yeah.
Okay. Okay, so then that's part of our answer, isn't it? So if we go back into Moodle, let's just put this answer in. Actually, I don't think I have this in Moodle anymore, but wish I did. I wanted to show you one other little thing about this. So that's the first part. They wanted the function, right? Now they also wanted the coordinates of the vertex. So what would those be? Yeah, okay, I'm going to get 9 because it's x minus h quantity squared, right? So h must be 9 and k is negative 15. Okay, now when we try to do this in Moodle, I've noticed people doing this quite a bit. I want to show you something. I don't think I've ever really pointed this out adequately. There's a feature in Moodle that's useful. Okay, so we could probably just do this one, I bet. Maybe even on our heads, right? If we subtracted 5 from both sides, if I completed the square, what's b in this problem? 3. Oh, b is 6, right? So b over 2 is 3. So I'm going to add 3 squared, or 9, to both sides, right? And I know that when I build my function, then on the right side, I'm going to end up with an x plus 3 quantity squared. Agreed? Okay, so if I use a couple things that you should know about. So first of all, if you use these parentheses, if you open up a quantity in the equation editor in Moodle, that's kind of nice because it'll stretch and shrink to match whatever's inside it. So if they're fractions, it'll stretch the parentheses, and otherwise it won't. So this time we get x plus 3 quantity squared. And then on the other side, we would have had a negative 5, but added a 9 to it, right? Which would have given us 4. When I subtract that back to the right side, I'd get negative 4. Okay, now what are the coordinates of my vertex?
3.
Okay, negative 3, negative 4. Now, a lot of people have done this. They've entered it like this, negative 3, negative 4. Okay, there's something wrong with that, though, isn't there? We need parentheses. Now I want to show you something about this. It's kind of cool. If you actually use the equation editor, so if you don't enter it as a string, if you go into the equation editor, look what it does. It highlights stuff in pink. When it highlights stuff in pink, it's telling you that something is inherently wrong with that answer. It's not even formatted right. You're not answering the question. Does that make sense? So whenever you have something highlighted in pink like that, if you hit submit or check, it's guaranteed to be wrong, 100%. So it tells you that it needs to be in parentheses. And so if I put this in parentheses, look, now it takes the pink away because now it's formatted properly, right? Okay, make sense? That's useful. Okay? How about that? Okay, what about this? Now, this could come from any assignment. On that first assignment where you started solving these kinds of big quadratic equations, that's when we were completing the square. And a lot of you, and it's fine if you like it this way, it's fine. But as far as I'm concerned, when you're solving equations, you can use the quadratic formula if you want. I don't care if you solve equations by completing the square, because you're probably never going to do it. You're going to always just use the quadratic formula. Now, on the ones like the problem we just did, you have to complete the square because we're putting a function into vertex form. But for something like this, we might as well just use the quadratic formula, right? So let's go through one of these, and then I think we're good to go. So what is the quadratic formula? Negative b plus or minus
square root b squared minus 4ac divided by 2a.
Good, divided by 2a. And we know that that's the formula that works when we start off in standard form. It has to be ax squared plus bx plus c equals 0, where a is positive, right? So we have that though, don't we, in this case? What's a, what's b, what's c?
A is 5,
Okay.
b is negative 10, c is 7.
C is 7, good. So if we just plug that stuff in then, we get x equals, what's negative b?
Negative 10.
Okay, good, positive 10, isn't it? Because it's the opposite of b, and b is starting off as negative 10. So we get 10 plus or minus square root 10 squared. Very good. We don't square a negative, we always square a positive. Minus 4 times what?
Times 5.
7.
All divided by
2 times 5.
2 times 5, which is what? 10. Okay, well, let's simplify. So that gives us 10 plus or minus, what's 10 squared? 100. 4 times 5 is 20, times 7 is what? Okay, 140, so 100 minus 140 is what? Okay, a couple things we can do to that. And then on the bottom, we still have our 10. A couple things we can do. For one thing, we have a negative there. What's that mean? We get an I. And then we could also simplify the square root of 40, couldn't we?
Yeah.
Right? What's a perfect square that divides into 40? 4. So 40 would be 4 times 10. If I use that perfect square, so if I do that, the square root of 40 equals the square root of 4 times the square root of 10. And then, is there a perfect square that goes into 10? Nope, so we're done, right? Square root of 4 is 2. So I can simplify the square root of 40 into 2 times the square root of 10, right? Okay, so then we just get 10 plus or minus 2 times the square root of 10, and I got to get my I out there, right? All divided by 10. Okay, but there's one last issue. We got to simplify this, right? We've simplified the radical, but we haven't reduced the fractions, right? And being as we have an I in this, we want to break it into a plus bi form anyway, right? Let's get phones away, please. So then I'm going to split this into 2 separate fractions. So I'm going to get 10 over 10 plus or minus 2 times the square root of 10 over 10 I. First fraction reduces to what?
1.
How about this one? Yeah. Right? So then I just end up with on the top, what's on the top of my fraction?
10.
Just the square root of 10. 1 times the square root of 10, we wouldn't write the 1 there, would we? We just get square root of 10 over 5i. So they're both of my solutions. Okay? Okay, last one. There's one more I forgot about. This is really a quick one, though. Okay, this is off the newest assignment. Okay, so what about this? Look what this is asking us for. These are really quick questions. Very, very quick. Okay, all these want to know here is they give us some quadratic function, and we're going to have to, process that appropriately. But all they want to know here is a discriminant based on the above equation has what kind of value? All we care about is it positive, negative, or zero, right? That's it. And based on which one of those three it is, that also tells us how many solutions, real solutions it has, right? Okay, now what was the discriminant? We're talking about the discriminant here. What did that mean? Remember we said that's the part of the quadratic function that discriminates among all the choices of the possible outcomes. For example, we could get two real solutions, right? Or we could get something different. If we go back and look and just stare at the quadratic formula for a second, what's the part of the quadratic formula that determines whether we're going to get reals or imaginaries? Yeah, it's got to be the square root part, doesn't it? It's got to be the number that we assemble under the radical. If it's positive, we're going to get two different real solutions, one for each outcome, plus and minus, right? If it's negative, I'm getting i's for sure. So I'm going to get two different possible solutions with i's, so two imaginary solutions. And then the sort of the weird in-between one, what if it's exactly equal to zero?
It's 1.
Yeah, then this whole part up here in the quadratic formula, the plus or minus the square root of the discriminant, well, the square root of 0 is 0. So really that whole thing just effectively goes away, and I just get negative b over 2a, right? That's just one answer. There is no plus or minus anymore. It's just one answer. So, oops. So then what do we get here? What do I have to do to this function, first of all, first? Because the discriminant is a part of the quadratic formula. And the quadratic formula only works if the function is in standard form, right? So what do I have to do to put this in standard form?
Add x and add 1.
Add x and add 1. So if I do that, I get 4x squared minus 2x plus 1 equals 0, right? So if I calculate the discriminant, you don't even probably have to do the math. You can probably just look at this and determine, most times, what's the sign got to be. If I do b squared minus 4ac, b squared is 4. So I'm going to get 4 minus 4 times, which is 4 times 1. Well, that's a positive number bigger than 4, isn't it? So all we care about is that it's 4 minus a big positive. So what's my outcome going to be? If I get 4 minus some big number, what kind of sign am I going to get for my discriminant then? It's got to be negative, doesn't it? Right, so if it's negative, if the discriminant is negative, then how many real solutions is it going to have? 0 real solutions, right? Because it's going to have i's in the solutions, right? Okay, make sense?
Wait,
Okay.
so how do you that was gonna be
Because it's 4 squared, it's b squared minus 4ac, and a is 4 and b is 1. So it's 4 squared, or 2 squared, sorry, which is 4, minus 4 times 4 times 1, which is minus 16. 4 minus 16 is negative 12, right? But in this case, they're small enough numbers that we can do them pretty easily. But what if they were really weird numbers, like decimals or something? Then a lot of times we don't really want to go through the hassle of finding out what the actual value is if we can just see very obviously that it's going to be positive or negative, right? Like for example, here, I'm going to show you one other. What about this one? What if I had something like, what if I had a really big value of a? So say I had 100x squared minus 2x plus, or not, how about minus? Minus 370 equals 0. what's the discriminant gonna be there for sure? If I do b squared minus 4ac, I'm gonna get 4 minus 4 times 100 times negative 370. How many negative signs do I have there? 2, right? So I'm gonna get a positive outcome. I don't even have to do the math, do I? Man, those are big numbers. I don't want to do that arithmetic. But I know it's gonna be positive, and so that's all I care about. I'm gonna get 2 real solutions. Okay, make sense? Okay, 332.